Today is July 19th, 2026. We have multiple days of severe weather coming up, as well as a tropical system that's trying to get its act together in the Gulf. My name's Dylan. Welcome to the forecast for Dylan. Let's get into it. I'm going to start off with our multiple days of severe weather I mentioned to you a minute ago. So, tomorrow we have an enhanced risk for severe weather over portions of Iowa, Wisconsin, and a couple counties in Minnesota. Right, this is for a 5% Sig 1 tornado risk, a 30% Sig 1 wind risk, and a 15% Sig 1 hail risk. On day 3, Tuesday, July 21st, we also have an enhanced risk for severe weather. Now, we don't have those granular probabilities yet for the tornado, the wind, and the hail. But we can see this is a 45% Sig 1 on the probabilistic outlook. So this is like borderlining a moderate risk. Okay, and so this is why I think this will go up to a moderate risk in tomorrow's forecast. But I'll tell you a little bit about that later. We still have that day 4 15% risk over here in North Carolina. This includes Raleigh, Fayetteville, Charlotte, and Winston-Salem. It includes Virginia Beach and Richmond, Virginia. It also includes a little bit of Washington, D.C. And now it stretches down into South Carolina. This includes Florence, Sumter, Columbia, and a couple other counties here in South Carolina. Now, what I will say is the primary threat for the entirety of the next 3 to 4 days looks to be damaging winds, but Monday and Tuesday could have an embedded tornado threat. Let me tell you a little more about that. Let's take a look at the 18Z HRRR for tomorrow's severe risk. This is the closest HRRR run that's in range. So we're going to just start off with the simulated radar here. This morning convection will move through. It'll enter the primary risk zone starting about 5 a.m. and it'll just keep going until what is this, like 12, 11? It'll finally push out. So as with the Midwest this season, that morning convection is going to play a big part in how the rest of the risk tomorrow actually turns out to be. If it clears out a little sooner than expected, we could see possibly supercells earlier that start to get their act together. If it moves out later than expected, we could see later supercells. And even like if it moves out later, we could possibly see less supercellular activity and more of like a Boeing line segment type thing. So it all depends on the timing of this morning convection, and that'll really determine our risks. Because if we get more supercells early on, we have a higher tornado risk. If we get less supercells later on, and it eventually turns into a Boeing line segment, we have more of that risk for damaging winds. So first up, I want to look at timing for this severe threat tomorrow. It looks like these supercells will start to form between 5, 6, and 7 p.m. Eastern time. This is central for these folks to subtract an hour. I'm not good at keeping up with that central time. We'll have these supercells roll through until 9, it looks like. And actually, on the latest HRRR, it has more supercellular activity, it looks like. Yeah, so we've got supercells until 7, 8, 9 p.m. Eastern time. At around that point, it'll start to form. You can see like a line here. But yeah, up until then, it looks like the HRRR wants supercells. And remember, our tornado threat is kind of dependent on those supercells, right? More supercells equals the higher threat for tornadoes. So the fact that we're seeing this in this 18Z HRRR is actually really interesting because it means that the HRRR is probably going to uptrend into an environment more favorable for tornadoes for tomorrow. Let's take a look at what these storms are working with. This is the instability, otherwise known as CAPE, or convective available potential energy. We can see starting off at 2, 3 p.m., this big plume of energy builds back off towards the west, and some of these storms will tap into it. We've got CAPE values between 3,500 and 4,000 in some places joules per kilogram. And that is going to stick around until between 8 and 9 p.m. Eastern. That is between 7 and 8 for these folks. So that is more than enough energy for these storms to get going and start working their magic, really. If we take a look at the low-level wind shear, here it goes. We've got a lot of that in place. And something interesting is that, kind of as we go later on in the evening, more of that wind shear starts to build in. So that's going to be really interesting. This is at the very lowest level of the atmosphere. This is the first kilometer up. So depending on kind of when that wind shear is able to be utilized is going to also determine our tornado threat. As we can see, we've got plenty of low level wind shear. It is not a concern. Starting off at 5 6 p.m. we get that, and it's there until the end of the event. I want to show you the significant tornado parameter, and this is actually uptrending with the 18ZH I had to look at a couple soundings myself just a second ago and see what the HRRR is really up to. We get that tornado juice start to build in between 2, 3, 4, 5 p.m. and it's going to be there until 9 or 10. So it kind of looks like it kind of shifts down south toward the Wisconsin-Illinois border as we go a little bit later. But yeah, that tornado juice effectively is going to be there throughout the entire event tomorrow. So it all depends on storm mode. Basically, we can take a look at the storm relative helicity at the lowest level of the atmosphere, and we can just take a look like at 9 p.m. west of Milwaukee, 576. I mean, that's a lot. We have multiple pockets of a lot of that starting 6, 7 o'clock. We've got multiple areas where that SRH at the lowest kilometer of the atmosphere is 400, 420, more realistically between 300 and 400. So, like I said, we have a lot of tornado juice. All right, so we've got that ability for those storms to start rotating if they can maintain that supercellular storm mode. Speaking of supercellular storm mode, let's take a look at the supercell composite parameter. This is another, it's a composite, but it's decent enough to look at. Take a look at some of these values. We've got 18, what is that, 20, 21, 22 in some places. Down here near Madison and Milwaukee, we've got even more of that. Yeah, 20 to 21. So we have that potential in the environment for these to stay supercellular, it looks like. So, if that persists and our environment keeps that up with that potential for these storms to stay supercellular, they could stay supercellular for several hours and pose a stronger risk for tornadoes. Here's the simulated rotation tracks, and it gives you an idea of what the HRRR model thinks these rotation tracks could look like. You see, it's got some gnarly ones down here near Milwaukee going across the lake here and north of Chicago. It's got these rotation tracks. This is where the model thinks that a rotating supercell could, survive and keep on chugging, basically. I'll show you the RFS just for comparison, and we know this has, an over-convection bias. It's actually got a little bit less CAPE than the HRRR on 18Z, but if you take a look at the UH tracks, you can see the RFS kind of shows that same thing. So it shows these supercells rotating and rotating for several hours, potentially, here in northern Wisconsin to the west of Chicago, and they go all the way across the lake here. We have decent STP values on the RFS. Let's take a look at supercell composite. Not as much as the HRRR. So the RFS maybe doesn't want these storms to maintain supercellular for as long. I think on the 18Z run in particular, if you look at the RFS versus the HRRR, I think the HRRR actually has a little more over convection, and it has more confidence in those storms staying supercellular. If we can take a look at the storm relative helicity on the lowest level of the atmosphere, it's still a lot on the RFS, even later, but it's not quite as much as the HRRR has. Let's take a look at that risk for Tuesday, July 21st. And as we can see here, we'll just take a look at the timing. This is on the RFS, so it could be a little later. I don't think it'll be any earlier than this. This shows supercells start to build in around 1, 2 p.m. Eastern time, and really lots of supercells by 5 Eastern, and they really just keep on going. It looks like they form like some kind of semi-discrete thing by 8, and by 10 it's a line basically impacting New York, Washington D.C., Albany, maybe even as far north as Boston. Our primary tornado threat is going to be where that enhanced risk is, so in this kind of zone here that I drew. We can take a look at some of this. Let's look at updraft helicity tracks And as we can see, the RFS has a lot of simulated rotation tracks, so it thinks that these storms could maintain the supercellular storm mode, rotate, and continue to rotate for several hours. We can look at the Cape. And one thing I noticed, the RFS and the HRRR for Tuesday place a lot of that instability back more towards west, so it'll be interesting how this actually plays out, but we still got plenty of it. I mean, what is that, 2,500 joules? Yeah, 2,500 joules per kilogram of Cape. That's enough for these storms to form and get going. Let's look at the SRH at the lowest kilometer of the atmosphere. Not really a lot. Until we get to 4, 5. Looks like our peak will be between 4 and 5. We've got that SRH at the lower level of the atmosphere. We can look at the low level wind shear. Not a lot of it. So I am really, I'll be honest with you. I can't really make a determination on the tornado threat for Tuesday right now. It just seems like the models have been so back and forth, and nobody really knows if there's going to be a large tornado threat or not. We know the primary threat is going to be damaging winds, but the models really just can't decide enough for me to make a determination and tell you that tornadoes will or will not be a big factor. That is one thing I've noticed. We can look at the STP just as something to look at, and there's not a lot of it. I mean, there's little pockets of a lot back over here towards the east, but I don't think. Oh, okay, they will take advantage of that. Okay, so these storms here to the west of New York, here in Pennsylvania, may pose kind of more of a tornado risk. By the looks of it, they'll take advantage of that additional tornado juice, and we've got high supercell composite parameter values over here, so the RFS thinks that these will be able to, kind of maintain that supercellular storm mode for a while and continue to rotate. Now, does this mean that our significant tornado potential is high? No, it just means that some of these storms, or maybe even a lot of these storms, could rotate and continue to rotate for a longer period of time. When it comes to severe weather, always remember to be prepared. Know where your storm shelter is. That is a basement if you have one. If you don't have one, it's the lowest and centermost room of your home. Okay, you want to put as many walls between you and the outside world as possible. All right, don't be scared. Be prepared. When you hear that tornado warning, act. I spent a lot of time talking about severe weather. Now I want to talk about the tropics. As you can see, we have a cone for this tropical storm that is expected to form down here in the Gulf. It's going to start off as a tropical depression, and it's going to emerge into a tropical storm, it looks like, by the time it gets south of Louisiana. No, south of the Florida Panhandle. And it's going to maintain tropical storm intensity. The folks on the coast of Louisiana, the coast of Mississippi, and the coast of Alabama will receive tropical storm coastal impacts, and then it will make a somewhat landfall here, looks like near Houston and San Antonio. So these folks that just received catastrophic flash flooding last week are maybe under the gun for it again as this potential tropical storm makes a landfall over here, and it's going to bring lots of tropical rain and that storm surge. We can take a look at the Euro model, and we can take a look at the precipitation type and the MSLP here. We can see we've got a 1009 millibar low pressure here in the Gulf. And the Euro, I'm going the wrong way. The Euro actually thinks it will, kind of subside on the coast of Louisiana. So that's kind of interesting. I think the GFS wants it to go farther over here, like the National Hurricane Center thinks it will. But as you can see, we'll have that tropical rain in place for a while over here because of this tropical storm. And so if we look at the total precipitation accumulation, we'll see a lot of that is going to be received on the coast of Louisiana, Alabama, and Mississippi over here thanks to this. And the GFS really doesn't carry it as far west as I think it could be. But as you can see how much you see how much rain this thing is going to dump over in the ocean. It's going to be a lot. Not a lot of rain on the coast of Louisiana and Alabama and Mississippi, it looks like. So these folks might get off easy. Let's take a look at the GFS because I'm curious. And no, the GFS isn't taking it that far west either. That's interesting. So the National Weather Service, the National Hurricane Center thinks it's going to go like this. The models thinks it's going to go like that. I haven't seen the spaghetti models. but the Euro and the GFS both think that it's going to do this one. So this is really interesting. Regardless of what exactly happens, wherever this thing makes its landfall at is going to they're going to receive some of that tropical rain, and flash flooding may or may not be a factor. The GFS doesn't really have a lot of rain associated with this, so that's interesting. Wherever this makes landfall, that tropical rain is going to be a factor. I found one model that wants this thing to make a sort of a landfall in Texas. It's got a lower low pressure than I think it's going to actually get. But yeah, see, this thing is going to barrel on and drop a lot of rain here near Corpus Christi, south of San Antonio. It might miss these folks over here who had that catastrophic flash flooding, because if we look at the total precipitation accumulation, all of this rain is going to be to the south of San Antonio, near Corpus Christi, and just the kind of lower part of Texas here. So these folks who got catastrophic flash flooding last week might get skipped, and unfortunately, they might receive a lot more rain, which is whatever of that flash flooding has subsided. It's going to just make that come back. Basically, it's the best way I know to explain it. Anyways, long story short, if you're anywhere within this cone, you need to be getting ready for that storm surge if you're on the coast potentially, and some lots of tropical rain. All right, the National Hurricane Center meteorologists know best, and this is the cone they've drawn. So, respect the polygon, respect the cone, basically the same thing. If you're within the cone, make sure you're making those preparations for that tropical storm. It did not occur to me how much yapping I did in this video until I looked at the counter and realized that it is 18 minutes long. All right, it'll probably be shorter for a lot of you, but I've been recording this for 18 plus minutes, not including my pauses. So apparently I've talked a lot. This is probably the longest one I've done in a while since the deep dive on that moderate risk in Illinois a couple weeks or months ago by now. Anyways, I digress. My name's Dylan. Thanks for watching the forecast with Dylan. I'll see you next time. Bye bye.